And so you push against the right side of the car, but that's because the right side of the car is trying to move left. And
You're
it's
sounding
pushing
like really Yoda-y right now. And you're like, actually, car move towards you. I don't know. Like,
yes, move the car does.
Yeah.
Hi, I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to Lesson 90. Cheryl, what bit of science do we get to learn more about this week?
Physics.
Physics. All of the physics.
Yes. When I think about physics, I think about my stepson who likes to call things physics.
Oh, really?
Like it's just physics, or like he like uses the term physics as like either an explanation or like why it's cool or like how it works. He'll just say like physics. I feel like he uses it in a lot of different ways. And there's moments where it feels like, I don't think that word means what you think it means. And then there's a lot of moments where I'm like, he's probably right. Like there's a lot that classifies under physics, I'm pretty sure.
I wonder, does he do much online? Is he aware of online things and memes and things like that?
Yes, he is.
I wonder if that's something that he's picked up from stuff online.
Ooh,
then?
probably. There's a lot he's picked up from
Yeah.
either like, or kids at his school quote things online, and then also he quotes things online. So some of the ones he's aware that they're from online, and some of them he thinks it's from kids in his class.
Okay.
It's like a
because,
combo
and I don't know if it's specifically physics or science or whatever, but a thing that sometimes you hear, especially online, is when someone's trying to explain something, they might say, because science or because physics.
I think I say that sometimes too, but I
Sure.
feel like maybe he says it like that. I'm not sure if it's like related. Yeah.
Well, anyway, we want to find out what is physics.
Yeah.
And to do that, Cheryl, we need to do our pre-assessment and find out, what do you think physics is?
Ooh. Intimidating is what I think physics is.
Why? What's intimidating about it?
Well, science is intimidating in general, but I feel like physics involves math, and math is intimidating as well.
Okay.
And okay, so like biology feels hard because of memorization, right? I've said this before. Physics feels hard for like a totally different reason. And that's more just like, it feels like it's more about like the moving parts, or like the, literally, and so it's just like these things and these concepts that I'm sure like if you knew the foundation, then it all works together and everything. But yeah, and also maybe it just feels intimidating because I don't think I've ever taken a physics class. I think it's been covered in like science classes I've taken, but I haven't like had a chance to dive into it or anything. And so it just, it's like I think I could like, but I'm trying to figure out how I would define it or describe it. I think it has to do more with how things interact with each other, or how things behave, than about a classification of what the thing is. Like Newton's laws, I think, are physics. They're about motion and everything. So I think it's a lot about like movement and what things do when they're moving, or like, what properties things have. Yeah. So I think that's like the aspect that physics is looking at in science.
Okay. You mentioned motion. Are there other categories of things that you think physics would investigate? So things moving, what else might physics investigate?
I think it would just gosh, this is gonna be too broad, but isn't it like the same root as like the physical world? But that's like what
Okay.
science is, it's about the physical world.
Uh-huh.
But maybe about like weight or size or just like the physical descriptions of different things and how and like what their properties
Mm,
are would be part of my dev. I'm guessing you would need to be good at like geometry to be
okay.
good at physics. I'm just trying to think of like I feel like this is probably just a much smaller slice of it compared to what all of physics actually is, as far as like what I
Mm,
understand it to be. But I think that's the theme with any of these is that
yes.
I have like a more narrow view of what that
Yeah.
field like actually all covers.
Yeah. Yeah. And that makes sense. Even though I know, Cheryl, that you said it kind of being a little tongue in cheek, you actually aren't that far off when you say that physics is about everything, everything physical, because it really is. There's
Hmm.
sort of I don't know if a joke is the right word, but there's an idea that biology is just applied chemistry and chemistry is just applied physics. And then some people would continue to say physics is just applied math.
Ooh, okay. Yeah.
And
That kind
so
of helps me understand how they relate to each other then. I like that.
yeah, and it's not quite that simple and that straightforward, but there is an element of that where in order to really understand biology at a deep level, you've got to understand chemistry. And in order to really understand chemistry at a deep level, you've got to understand physics. And in order to be able to do physics, you've got to do math, like you said. And
Yeah.
there can be math in all areas of science, but physics is the one that it's mostly apparent. If you take a physics class, you're doing a lot of math. I used to joke that physics is just math in disguise. It's like all story problems all the time. That's basically what
Yeah,
physics
yeah.
is, which most people are not huge fans of that. But the reason is because, sort of like you said, what physics does is it describes how the physical world interacts. And you can basically split the physical world into sort of two realms that I think we've talked about a little bit before, but matter and energy.
Mm,
Does that
mhm.
sound familiar?
Yep. Yeah.
And when you look at physics, physics deals with both of those, matter and energy. When you deal with the matter side, you're dealing with, like you said, how things move and forces and cool things like quantum mechanics, which is very exciting, but also very weird. So you've got stuff dealing with matter over there. And when you deal with energy, you can deal with things like light and heat and sound and waves, all of that stuff is how energy tends to move through. And both of those fall into the realm of physics.
Mm.
Does that make sense?
Yeah.
And then in order to do those, physics often is trying to predict what would happen if I do this, what happens now? If I change this, what happens? And you mentioned Newton's laws of motion, for example.
Mhm.
What a lot of physics tries to do is describe the things that we observe mathematically so that we can predict how it's going to do it in the future.
Mm.
And that can be with, if I push on this object with a certain amount of force, how fast is it going to move away from me? Right? Or how much force is it going to take to move this thing at a particular speed? Or whatever those, if I'm turning, what is that going to do to the motion that I have, or
Yeah.
optics with light is really cool. If I shine light through a window, what about the light changes as it goes through the window than when it wasn't through the window? Or how my telescope works, because either my light beams are bouncing off of a mirror or they're bending through a lens, or how your contacts work or your eyeglasses, all of those things as far as
Yeah.
light, like there's all of this stuff. We've done some physics on this podcast, our hot and cold unit. There was some chemistry in there, but a lot of that was also physics. There's a lot of overlap when it comes to this realm called thermodynamics.
Oh,
Thermo
yeah.
meaning heat, and dynamics is like changing, how things are changing. And so thermodynamics is the study of how heat and that type thermal energy kind of moves and changes. And some of that is in chemistry and some of that is in physics. And so we've done some of that already.
Yeah.
One of the other big things that falls under physics is gravity. Gravity is a force, unless you're doing general relativity, and then it's not a force.
Oh boy.
Which that makes sense, right?
Yikes. No, not at all.
Not at all. Gravity is really exciting. And one of the other things that's interesting is physics very quickly connects to astronomy as well. Most people who are astronomers are physicists first. They typically would major in physics. You may have heard of astrophysics.
Yes.
I don't know if you've heard that term.
Yeah.
So it's the physics, but as it applies to space. And it's different. I wouldn't say it's pure physics. For example, I've told this to some of my astronomy students before. There are certain things that physicists get really passionate about that astronomers don't care as much about. For example, you may have heard of the difference between centripetal and centrifugal force. Have you heard that before?
I've heard the words.
Yeah. So if you talk to a physicist, often, especially a physics teacher, they will usually be very adamant that centrifugal force isn't real. We shouldn't deal with it. It's centripetal force. That's all we need to deal with.
What a nerd.
Yes. And while on one level that is true, centrifugal force is not a real force. Astronomers talk about centrifugal force quite a lot, even though they know that it's not a real force, because it is a perceived force. It's something that we perceive or we feel. Here's the short version. So if you're in a car and you're driving relatively quickly and you turn the steering wheel to the left relatively quickly, what do you feel?
You like lean. You have a lean.
You have a lean.
Yeah.
The car is going to the left. It feels like you get pushed to the right. Would you agree with that?
Yeah.
Right? That feeling that you have, that you're being pushed to the right, that is centrifugal force. It's being pushed opposite of the direction in which the car is turning. The reality is there is no force pushing you to the right. It's actually centripetal force, which is actually pulling you inwards. But that's not what you feel. Cheryl,
it's
the expression on your face
inwards?
right now.
Which way is inwards? Like inside of your body? Or like inwards towards that left turn?
Towards the left turn. Yeah. Here's the short way to hopefully help it make sense. Okay. So I'm going to try to do this with my hands to see if this works.
Okay.
Oh, cool. Ooh, I got to see which way is left and which way is right. If I bend this way, what direction is that for you?
That's my right.
Okay. So I'll go the other way so it matches for you.
Okay.
So this way is left for you.
Mm-hmm.
Okay, great. So
I'm so
if you're
glad
driving,
our science teacher learned his left from right now.
Well, it's opposite for me.
No, I know.
So you're driving, and in this case, I'm going to go up and down, but we're just going to pretend like we're looking from above, right?
Sure,
so you're driving and you're going straight.
Yeah.
Right? If you are in motion, you're going to stay in motion. That's Newton's first law, the law of inertia, right? Objects in motion tend to stay in motion. Does that sound familiar?
Yes, it does. Yeah.
Okay. And so you're going to keep moving. If the car begins to turn to the left, right? That's the direction we said that was.
Yep. Yeah.
Okay. The car begins to turn to the left. What direction are you going to be going?
To the left.
Not initially, because you're moving straight.
Oh, and
It-
that's that feeling that it's
So
to the
you're
right.
going to
Yeah.
keep going straight, but the car, because it's in contact with the road, is going to start moving essentially underneath you.
Mm,
Does that make sense?
yeah.
Okay. You're still going straight. The car is now starting to turn, which means it's pushing against you and pushing you in that direction. Does that make
Okay.
sense? It's pushing you towards, well, you're being pushed into the, see, this is backwards for me. So this is like tricky for me because I'm trying to show you in your direction, but I'm trying to picture it in my direction.
Yeah.
You're feeling that you're being pushed towards the right,
Yes.
right? But what's actually happening is the car is moving towards you and you are trying to continue in that same direction. And so you push against the right side of the car, but that's because the right side of the car is trying to move left and
You're
it's
sounding
pushing you.
like really Yoda-y right now, and you're like, actually, car move towards you. I don't know, like
Yes, move the car does.
yeah. I think I get what you're getting at, like that the
But
real
this is
force versus like the perceived
exactly. And this
force.
is what I'm saying. Astronomers are like, yeah. We know the direction the real force is, but also we just care what you're feeling right now.
Wow.
And pure physicists don't generally like that very much.
Interesting. That's funny that
Yeah.
any scientist cares what you're feeling.
Well, it's not, I say what you're feeling, it's not your
Yeah.
emotions, it's
Yes,
what you're
yes.
experiencing. Because,
Mhm.
well, because this whole thing called frame of reference, which you don't need to really worry about, but this is a big physics thing. I think you can understand this. Frame of reference. Right now, would you describe yourself as moving?
No,
Why not?
because 'cause I'm sitting down.
Mm-hmm.
But I know, like, what you could say, though, is that, like, the Earth is moving, and so I'm
Yeah,
moving. Yeah.
exactly. That's your frame of reference. With your frame of reference being the surface of the earth, are you moving
Mhm.
right now?
No.
No. And that is completely legitimate. If the frame of reference was the surface of the sun, now would it appear like you are moving?
Yes.
Yes, it would.
Yeah.
Because it's a different frame of reference. Well, which frame of reference is the right one?
Neither?
Neither. There is no correct frame of reference. Yeah.
Yeah.
And
Yeah.
so that's something that in physics we have to do a lot. You have to just define your frame of reference. This is the essence, it's much more complicated, but the essence of the idea that things are relative. You've probably heard that
Mm.
term before
Mhm.
too,
Yes.
right? So your motion is relative or compared to your frame of reference. And
Mm.
we can define it all in different ways, all depending on where you have your frame of reference. And so astronomers and physicists look at those a little bit differently. Again, you don't need to worry about that. It's not a super big deal for you in your life, but it is true. And you have probably heard things like that.
I feel like, a phrase that feels similar to that is, "It's 5 o'clock somewhere."
I mean, I guess, yeah, that sort of works because it is true that it is 5 o'clock somewhere. Somewhere on Earth, it is 5 o'clock. That's true. It's not exactly the same thing, but sure, the spirit of it is the same.
It's relative, right? It's like, "Well, is it 5 o'clock?" It's like, "Well, I don't know, where are you?"
Yeah, that's true because time is not something that is absolute in that sense. Like the time on a
Yeah.
clock is
Yes.
defined by what we say and where the sun is in the sky, which depends on
Yep.
where you are on Earth and where it is in
Mhm.
its rotation and revolution and all of those great
And then the
things.
second you do daylight saving, you're like, "Oh, none of this actually matters or is true." It's
Stupid.
just like, now we call it a different time. So,
Hmm.
yeah.
But only some places, because other
Yes.
places you don't.
Uh-huh. So then it is like, what is time?
Yep. Yep. Valid point.
Daryl hates that phrase because If you think about it as in 5 o'clock on the dot, he's like, "No, no, it's not." Because
Oh,
unless it's like the turn of the turn of the hour, that's not the phrase, but like exactly on the hour, then
yeah.
he's
Yeah.
like, "No, it's actually not 5 o'clock anywhere right
Yeah.
now."
Well, and then if you want to make it even more complicated, did you know that there are certain time zones that aren't that don't change by hour? There are some time zones that are like an hour and a half ahead.
What? I don't know about these ones.
Yeah.
What?
Yeah.
Where?
There are some times I don't remember. I'd have to look it up. And this has nothing to do with physics now. We're totally off in left field. But yes, there are some time zones. Like we think, oh, they all go 1 hour at a time. No,
Yes.
they don't. Some of them go
Oh.
ahead. I think there's even some that are like by 15 minutes or by 45 minutes or
Oh
something like
my
that.
goodness. So it really is 5 o'clock somewhere then.
It might
That's
be. It
true.
might be more likely to be 5 o'clock somewhere than initially we thought. Now, Cheryl, let's do your physics quiz.
Yeah.
And I think if
It's
I
quiz
understand,
time somewhere. There's my
it's
joke. We got
there
there.
it
Yep.
is. There it is. And I think if I understood you correctly, you wanted this to be an all math quiz, correct? All story problems.
Yikes. Yikes. I could do about like arithmetic level. So if it's arithmetic math, then like
So a train
there we
leaves
go.
Seattle going north at noon, and another train leaves Vancouver, BC going south at 2:30. What time? No. Have you
What
have you have
time
you
which train do I need to book to make my
what time will they
reservations
both
that
reach Blaine,
evening? And yeah.
Washington?
Mhm.
Except I
Yeah,
didn't give you a speed for them, so you wouldn't be able
I
to
know.
figure it
I
out.
actually
So,
did enjoy those problems a lot. I thought they were pretty fun because
oh,
I
really?
like yeah, I like those types of things, like anything that feels like a logic type of question.
Mm,
I like a
mm-hmm.
logic question a lot where you have to like
Okay.
take the almost like the clues, like the
Yeah.
information together to like
Yeah.
figure it out. I thought those were really fun. So
Yeah. That's a
yeah.
lot of physics. Really is very similar to that.
Ooh,
Yeah.
interesting. Maybe I would like it. Yeah.
Maybe you would. First question for your physics quiz. What are the two main categories of things that physics studies?
I believe it's the two main categories that all the scientists study and that everything breaks down to, which is matter and energy. And
Yeah,
then I
nice
think you
job.
said in a previous lesson that really you could argue it's all energy, but that's more complicated.
Yes, look at you remembering things. Good job. Way to
Sometimes I
go.
do, every once in a while.
Can you give some examples of specific areas that physics studies?
um, it studies everything. It studies everything.
Uh-huh.
That
That's why I asked for
it
specific
yes.
examples. Nice try.
And then I was gonna say the aspects it studies are like blah blah blah, but you did not ask me for a definition, so we're gonna skip that part. Specific examples would be trains, planets. Uh, you gave me a train question, so now it's
I
trains and
did, but
aspects.
like of the
Um,
areas, not of the objects that it studies.
oh, okay. We're gonna get there someday with this quiz
I hope so.
question. The aspects would be like movement and size and guessing what's going to happen based on what we know about those things or based on math and the properties of the object. This is where I'm just going to ramble
I've
for a little
noticed.
bit more. Yeah.
You started okay, and we're definitely going up. Sure. Size, I don't know about size. I don't really understand
Yes,
that
size
part.
would totally be like if you even like one of our first episodes, we talked about my professor who said that it'd be better to hit a person than like a big semi truck or a pole.
Uh-huh.
So like if you're gonna hit something with your car, the size of it really does matter as far as the impact on it. So I would say that size
Okay.
does have
Sure.
an
I don't know that that means that we
impact.
investigate size, but I see the
I think it
connection you're
is more
making.
like based on the size of something,
Yeah.
then there are different things that will happen.
Yes. Based on the size of something, different things will happen. That is a true statement. Yep. You could also have talked about forces or light or
Oh,
heat or
yes.
sound or
I see what you're saying.
waves. Any of those things would have worked as well. Why do physicists use math so much?
They're just obsessed. They can't get over it. I mean, because physics is math science. They need math in order to make their calculations, which is I think a lot of what physics is. So like
But
if they're
why?
going to make these predictions about what's going to happen, then they have to use math in order to make accurate predictions.
Yeah,
Like angles a lot, probably.
sure.
I'm just
Depending on what it
picturing
is.
like a cheetah. This whole episode, I've been picturing a cheetah jumping, and then
Uh-huh.
like you would need physics to know like, well, at what force did it jump and what angle and how high is the thing
Mm,
it's trying to jump on.
okay.
So I was thinking about
Sure.
angles.
The
Yeah.
angles of a cheetah. Got
Hmm.
it.
Yes, the
Yep.
cheetah angles. Yeah.
The cheetah angles. Great. What is the difference or a difference between centripetal force and centrifugal force?
One is real and the other is in our minds. One is fake or
Yeah,
perceived.
perceived. Yeah.
Yeah.
Yeah, that's great. That's all you need. You don't need to go any
Cool.
farther than that.
You're like, please don't. Please stop talking.
Don't ramble. You don't need to add anything. You're good. Stop.
No, this is why I
You're just
like
going to hurt
English
yourself.
class where I'm like, just keep writing more on the essay and like
Uh-huh.
you
Yep.
sound cool sometimes. Yeah.
You and Lucy Van Pelt.
I don't who's Lucy Van Pelt?
Lucy from like Charlie Brown?
That's her last name?
I think so. I think that's right.
Oh my
Do I
gosh,
need
I
to
didn't
look it
know
up and
that.
make sure?
Yes, you do. Did she ramble? I just feel like she was bossy. Did
Yeah.
she say that with
Lucy
school though?
Lucy Van Pelt. Well, so there was, have you ever seen, boy, this is a random episode. Could I just
Here's the
share that right now?
thing is this is our senioritis unit. So here we
Have
are.
you seen You're a Good Man, Charlie Brown?
Yes. Yeah.
Either the cartoon version or the stage show?
I've
Or
seen the stage
both?
show a couple times. Yeah.
Yeah. There's one, probably my favorite one, where they sing about homework. They're writing a book report on
Oh,
Peter
and she has to
Rabbit.
get to a word count.
Uh-huh. And she just
Very,
goes and
very,
goes.
very, very.
Uh-huh.
Yeah. Mm-hmm.
Yep.
Oh, yeah.
Yep. That's where I was going
If
with that.
you need a high word count, I'm your girl.
Yep. Good to know.
Yeah.
One more question on your quiz.
Okay.
What does it mean that motion is relative?
It means that this is where I'm going to use a lot of words. You could make an argument that something is moving or not, depending on what you're saying it's being compared to, or like what it
Mm-hmm.
is on top of. And if you're saying that that thing on top of it is moving and therefore it's moving, or
Mm-hmm.
so it depends on the perspective for if you're going to say that it's still because it itself is not moving or versus like it's moving because everything is moving.
Yeah,
Is
that
the
works.
sun even moving? We've
Yeah.
never talked about this in our solar system one. I
Mm.
assume that the sun is also moving though, right?
The sun is moving. It is rotating on an axis, just like the Earth rotates on its axis.
What?
And, oh yeah, and the sun and the entire solar system is moving around the center of the galaxy.
Wow.
Just blew your mind.
Yeah. We didn't talk about that part. That's so
No,
cool.
but spoilers, we're going to talk about what is astronomy
Oh my
in
gosh.
another episode or two,
I'm
so you
so
could bring it back
excited.
up if you wanted to.
Yes. Well, Ryan, before you can tell me to pack up my bags,
Okay.
I have a mini quiz for you
Oh,
with a
how the
topic that is
tables have
more
turned.
interesting to me. well, I'm going to say this is a travel topic, but it's actually not a travel topic. It's a geography topic. Um,
Okay.
Time zones. We were talking about time zones,
We
and
did.
I did a quick little Google search and learned everything I need to know about
Oh,
time
did
zones.
you now? Okay.
So I'm gonna have you. I know these are gonna be guesses. Um,
Uh-huh.
Guess which part of the world do you think there is a higher concentration of time zones that are not on the hour, but like on the 30 or the
Mm.
45?
Well, and it's a guess, but also remember I've seen this before, so I have a
Okay.
sense of where that is, although I think I could be wrong. To me, it feels like Southeast Asia. So kind of like Indonesia, like Indian Ocean, like that area, I feel like is where there are more of them.
Ding, ding, ding. Good
Hey!
job. It looks like the majority of them are right around there. There's like
Okay.
one country in South America,
Oh,
one
which
little
country?
teeny part of Canada, and then parts of
Oh,
Australia. Kind of that
Canada.
middle section of Australia has some as
Oh,
well.
I don't think I knew
Um,
that. Interesting.
okay, and then I will tell you what part. Oh, it's Newfoundland in Canada.
Hmm. And
And then you
what is
wanted to
Newfoundland?
know
Like,
Newfoundland
what is it
it's on
off?
a 30. It's
Okay.
UTC minus 330.
Interesting. Okay. Yeah.
And then the one in South America, it looks like it's Venezuela. I'm
Oh,
just kind of looking at
okay.
like a map, and so, but that's
Yeah.
what it
Yeah.
looks like. Okay, but one more question for you.
Okay.
How many time zones are there that are not on the hour?
Ooh. How many time zones? Oh gosh. Well, you've already mentioned ones that I didn't know, like Australia and Newfoundland and Venezuela. I feel like there was like, I don't know, 4 or 5 in Southeast Asia, so like maybe 10.
Ooh, that's a good guess. My count on this list is 16.
Okay.
Yeah, because even in
That's a
Australia, there's
lot.
several.
Oh,
Um,
interesting. Okay.
just in Australia, there are 6 that are like
Oh my
different
gosh.
ones. Yeah, there's like a plus 845 is one of them. I mean, yeah, it's just
Weird.
kind of interesting. So now we know more about time zones too, which sounds more like our travel podcast than
It
this
does.
podcast,
I would say
but it's about
in
the earth.
it is about the earth. In an act of extreme irony, physics, which tends to be the most straightforward, like you follow the rules and things always work this way, sort of science, we've gone off the rails on totally different directions that have nothing to do with it. So there you go. I think we'd better stop while we're not ahead, but before we do any more damage. How about that? So why don't you pack up your stuff and get ready for my closing remarks? You can follow us on Instagram and Facebook at I Slept Through Science or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.